Kia ora. We're having a look at page 25. So page 25 is locate the points where the curves have the given gradients. So pretty much the question is going to come in and be like, this is the function we're using. Where is the gradient equal to 6? So let's have a look at how to do this one. So I've got a curve on the left, and the function of the curve is f of x equals negative x bracket x squared minus 2. And I'm going to ask the question, when is the gradient equal to negative 1? Right? So, pretty much, if we were having a look at this on here, let's make this, oh, I can't make it bigger. So let's move this around. So at what point on this curve will the gradient be negative 1? So a gradient of negative 1 is going to be going downward, so I'll be somewhere around about here. But over here the gradient's too big, that must be like negative, yeah, it says on the left it's negative 7.72. So around about here, I think I just hit it perfectly. Around about here the gradient is negative 1. Oh, that's bang on. And then it's positive, 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 positive. There's no gradient. And then around about here it is also negative 1. So that's the question we're asking. Where on this function is the gradient equal to negative 1? So let's have a look at how we do it. So for these, the first thing we're going to do is differentiate. So we'll go f dash of x. But actually, this, we can't differentiate it yet. So we're going to have to do something first. So let's scrap that for a second. We're not going to do f dash of x. We're just going to write out the equation again, but expanded. I need to make sure I've really crossed this out. Right, so all we do is negative x times x squared is negative, because a negative times positive, x cubed. Then negative x times negative 2, that's going to get us to a positive, so it's going to be plus 2x. And now this is a polynomial, so this we can differentiate. So let's go f dash of x equals, so we will multiply by the power, that's going to be negative 3x, and then reduce the power by 1 squared. Then here it's just going to become plus 2. Now we want to know when the gradient is equal to negative 1. So normally what we do is we would substitute in a value for x and would output a gradient as the function. Right? So instead we're doing it reverse. We're going to say the output is negative 1. What will the input be? So here our x is our unknown. And because we have an equation with one unknown, this is solvable. We can see that there's a squared there, so we're going to have to deal with a quadratic, but I think it will be kind of nice. Now, see how I've got a negative here? I'm going to move everything over to the left. So I'm going to add 3x squared. I'm going to minus, oh wait, what did I lose there? I feel like I've done something wrong. Oh no. Yeah, and then minus 2, so now that's going to be minus 3 equals 0. So all I did was move things to the left because I like to have my power being positive. It's easier to factorize. Can we do any... Ooh, no. Actually, this is way easier to solve. I'm just going to go 3x squared. I'm going to add 3. Whoopsies, I added a step there. Sorry, guys. But I noticed now that I could divide both sides by 3. X squared equals 1. And then how do we get rid of a square? We just go x and then we go the square root, but whenever we do a square root we have to put plus or minus. So the answer is x is positive and negative square root of 1. What's the square root of 1? It's 1. So then we know that x1 is going to be the smaller of those, it's going to be the negative one, and x2 is going to be the bigger of those, the positive one. So we have just located the points where the gradient is negative 1. So at negative, when x is negative 1, the gradient's negative 1, and when x is positive 1, the gradient is negative 1. Let's have a look. I'll substitute those points in, negative 1, voila, look at that, the gradient is negative 1. Also, when we put in the point 1, the gradient is also -1. So those are the only 2 points on the graph where the gradient is exactly -1. Now, let's see if there's any questions that you might get caught up on. Where the gradient is -3, where the gradient is horizontal. What does it mean to be horizontal? Well, let's move this until it's horizontal. Not quite horizontal. Ooh, 8.3. No, 8.2. Ooh, nearly. 8.1. Oh no, it's 8.2 something. Ooh, 8.2.0.1. So see how this is when the gradient is horizontal, and that's when the gradient is equal to 0. We're getting close to 0 here. I'm just not able to quite hit it. We need to go something a little smaller than that. 8.199. No. 8.1.8. Ooh, we're getting closer. Yeah. Anyway, horizontal gradient means gradient of 0. Let's have a look at some other ones here. When the gradient's -1, you'll just substitute -1 into there. -4, easy. Gradient is 0. Gradient's -24. All of the rest of these are just substitution. So all you're going to do is differentiate, substitute the gradient in for the whole left side, and find at what x values. X will become your unknown.